Hi there and welcome back to another Popetti Math YouTube video tutorial, where today I am going to be teaching you Algebra 1. And in this lesson we're going to finish up our exploration of quadratics in Chapter 9, and we're going to sum it all up with exploring real-life scenarios found in Lesson 5. It says you have reached the real-life applications for quadratics. You will find that many times the real-life scenarios deal with projectiles being launched or thrown in the air. Tracing the path of these projectiles is where your knowledge of quadratics is going to come in quite handy. Exercise number 1 says the graph below shows the height of a rocket h of t after t seconds the rocket is in the air. The full flight of the rocket could be modeled by the equation h of t is equal to negative 16t squared plus 128t. How many seconds was the rocket in the air is our first question. So the amount of seconds that the rocket is in the air is the amount of seconds, here's time on the x-axis, the amount of seconds that this graph is above the x-axis. So the rocket starts launched, it's launching at 0, and it goes up, 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 up. It comes back down and it hits the ground right at here, 8 seconds. So how many seconds has it been in the air for? 8 seconds. What is the maximum height the rocket reaches is our next question. And if we look at our graph of our parabola again, we see that our maximum height occurs here, but we don't have an exact value, which is not an issue because in our previous lesson, we saw how we could find the exact value. And the way we do that is we're going to look at our axis of symmetry. We know what our axis of symmetry is. And our axis of symmetry is x equals 4. So since x equals 4, we could find our vertex by substituting 4 in for this equation right here. So that's what we're going to do. We're going to have h of 4 is equal to negative 16 times 4 squared plus 128 times 4. And now we're going to multiply negative 16 times 4 squared, which is 16, and we're going to get negative 256 plus 128 times 4 is 512. And so h of 4 is going to be 256. So the maximum height that this rocket will reach is 256. And it says, does it give us units? The graph shows h of t. It does not give us units for the height, so we're going to say units because we're not sure if it's feet or meters or yards. We're going to say 256 units. And over what interval is the rocket's height increasing? So again, it's launched here and the rocket's going up, up, up until that vertex point. So we're looking at the domain interval, the x values over what interval is it increasing? So it's increasing from 0 is less than x is less than 4 seconds. So from 0 to 4 seconds, that rocket is going up. Now, in this question, we looked at how many seconds a rocket was in the air, what's the maximum height that rocket reaches, and over what interval the rocket's height was increasing. And if this video is helpful, please give it a thumbs up, and you're now ready for exercise number 2. Thank you for watching.